Students, we are back with another lesson. In this lesson, we'll discuss kinematic equation for uniformly accelerated motion. That means we will try to derive three equations, okay, for a body which is moving uniformly. That means it is accelerating at a constant rate. So derive the equation of motion for an object moving with constant acceleration along a straight line. So the first equation we have to derive is v equals to u plus at. Fine. So now consider an object moving with a constant acceleration along a positive x-axis. So suppose here I have drawn your x-axis. Now consider at time t equals to 0, this is the position of the object, and let us say it is moving with some velocity small u. Now consider after some time the object has changed its position and have reached this point x, and let us say at time t. So now at this point the object is moving, let us say, with the velocity small v. So now we will derive the velocity of the object at any time t. Yeah. Now we will do a derivation, or I'll say I will find out this velocity, or I will deduce a relation for this velocity on the basis of this initial velocity u, how fast it is moving, the constant acceleration a, and the time at which this velocity is measured. Fine. Now to derive this expression, now we know what is our acceleration. Our acceleration is the change in velocity upon time taken. So what is my change in velocity? Let's first write down the final velocity v, then write down the initial velocity u. The difference of this velocity gives us the change in velocity divided by the time it takes. So at this point the time is t, and at this point the time is 0. So the time taken is given as t minus 0. So if I simplify, I can write down v minus u upon t. Now I can send this t, I can cross multiply it here. Fine. Or I can also, or further simplification, what I can do, I can write v minus u on the left hand side, at on the right hand side. Fine. Now I can send this minus u to the other side. So if I send this u to the other side, I will have my final velocity v equals to the initial velocity, the sum of the initial velocity and the product of the acceleration and time. So this expression gives me the velocity, the final velocity of the object at any time t, which is moving with a constant acceleration a. Fine. So that's it for today's class. Thank you. And the rest, there are two more equations. Okay, we will derive two more equations in our next class. Fine. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. So again, thank you.